Hello, welcome back. Today, let's try to solve another Leetcode problem. 875. Koko eating bananas. So this is a very famous Leetcode problem. As you can see, there are so many people like this kind of a problem. Yeah, and we need to talk about the problem. So we are giving a piles. So that is an array, and we also have a Koko. So this Koko loves to eat bananas. So the Koko will eat bananas inside the piles. Yeah, and we just need to return the minimum number, the minimum integer k, such that they can eat all the bananas within k hours. So for example, this is 8 hours. So what is the minimum integer k? For example, here is 4. This 4 means they can eat the first piles because 4 is more than 3. Yeah, so we called it as 1 hour. And then they going to eat the second piles. How many hours? The first hour they finish 4, and another hour they finish 2. Because even there's only 2, they're gonna use the second hour. So this means 1 plus 2 plus 2 and plus 3. So that is 8. Yeah, and we cannot find a bigger number than that. Yeah, basically we are going to return the minimum integer k. Yeah, such that they can eat all of them. Yeah. What about they used 5 hours? Of course, because 5 is not the minimum. Yeah. What about they use 5 hours? They finish the first piles, the second piles. They used 2 hours. Here they also used 2 hours. They also used 3 hours. Yeah. But the result is 5 hours. It is not. Yeah. The speed is 5 bananas per hour. It is not our result. It can be smaller. Yeah. What if the speed is 3 bananas per hour? They can finish the first one 1 hour, the second pile is 2 hour, the third pile is 3 hour. Yeah, 1 plus 2 plus 3, it is 6. So the fourth pile they used 4 hour. It is 10 hours. It means it is more than 8 hours. It is not possible. So this is why they're gonna try 4 hours. But we're gonna not use brute force to try one by one to check if they can finish eating all those piles, because this number can be very big. Yeah, for example, this piles I, it can be 10 to the power of 9. Yeah, so this is why we cannot use this kind of a method to guess. Yeah, because if her speed may be very large, because this number can be very large. If this number is 10 to the power of 9, how should we guess? We have to guess from 1 to 10 to the power of 9. That is not possible. We have to use a binary search to guess, because in binary search, basically that is nearly log n nearly to 30 or 40. That is not a big number. And then we just going through the piles to check how many hours. If we can finish that more than, less than, and equal to 8 hours, it means our guess is right. If we finish that more than 8 hours, it means our guess is wrong. Yeah. So this is a typical binary search plus greedy idea to solve the problem. Now let's just go to the problem to finish. This kind of a Leetcode problem. Normally for such kind of a problem, we don't need to make a drawing or analyze. We just need to understand the question and use our template to solve the problem. Basically, this is a guess problem. For guess, we just need to use a binary search to guess, and then try to use the brute force or greedy idea to check if our guess is right or wrong. Yeah, if it is wrong, we're gonna guess another number. If it is right, we're gonna guess a smaller number. Yeah. Now let's just go to the function. Yeah, for me, when I'm doing this kind of a problem, I always use a guess for this threshold. Threshold is my number to guess. Here, I'm going to write a path first because I'm not going to write this function yet. I'm going to write the main function. For the main function, for the binary search, I'm going to use L and R pointer and the result. So for the left pointer, what is the smallest eating speed of Koko? Maybe 1 hour, 1 banana per hour, because they cannot eat 0 bananas per hour. Because this k is an integer, so what is the minimum? It cannot be 0. If it is 0, there's always bananas inside the piles, because piles less is like that, and the piles is always be more than 1 because there's always bananas inside the piles. If her eating speed is 0, how can she finish eating them? So it should be 1. Yeah, this is why. So the right pointer, the maximum should be, let's check. So we have a piles array, and the hour is always be more than and equal to this piles array. Yeah, this means here the hour is 8. So what if the hour is equal to this piles array? So the hour is 4. Yeah, if they want to finish that in 4 hours, because if it is 4, it is the minimum of the hour. Yeah, because it's less than, more than or equal to. What if it's equal to the length of the piles? It is 4. And what is her eating speed? It should be 11. It should be maximum of the piles, and then she can finish that. Yeah. So it will be the maximum of piles. So this is a kind of optimization. You can also use the L to R from 0 to 10 to the power of 9. It will also be okay, a big number. But here, this is the optimized solution. Yeah, if you have time to optimize like this. And the result should give a 1 or any number, because the result that doesn't matter. Because in the binary search function, you will gonna update the result. Yeah, if the L less than and equal to R, let's finish our template for the binary search. So M should equal to L plus R minus L divided by 2. Now we're gonna check. Yeah, so we're gonna check this number M. So M is the threshold inside my check function. So if I check this number, if it is okay, as I explained earlier, I'm gonna have a result equal to M. This means I guess the number, it may be too big, or it may be the right number. If it is 4, I'm gonna use the result equal to this guessed number. Yeah, if it is too big, so what am I gonna do? So I'm gonna update my R pointer should equal to M minus 1. This means it can be a smaller number. For example, my guess is 5. It means, oh, 5 is also true. What about a smaller number 4? Because I'm going to return the minimum integer k. Yeah, this is why here I'm going to use R equal to M minus 1. This check always means the check. I guess I use the number to check if it is true. It is always true. Yeah. This check is only return a true or false. Yeah, if my check is false, so I'm going to update the left pointer. It should be M plus 1. Because my guess number may be too small, I need to have a bigger number. So here I need to use M plus 1. Finally, I'm going to return the result. Yeah, but here, now let's finish the check function. So for the check function for this one, actually, it is easier. If you did a few binary search plus the greedy, like this kind of a problem, this pattern, you're gonna finish it easily. Now we're gonna use a count equal to 0, and for the final return, it would be count should be less than and equal to k. This means our check is right with this threshold. Now I'm going to check if that is okay. So for p in piles, this means for bananas in piles, yeah, I'm going to check if this, for example, this is my bananas. Yeah, if this bananas modular threshold equal to 0 or not, because I'm going to use division to count how many I'm gonna eat. Now I'm going to, let's check. I'm going to use p modular with threshold. Yeah, if p modular threshold, p is the bananas, 3 modular 4, yeah, equals to 0. This means how many bananas I'm going to count. So the count should plus equal to p divided by threshold. Let me give you an example. So if the bananas is 4, 4 divided by 4, yeah, because 4 modular 4 is 0, 4 divided by 4 is 1. So this means they only need to consume 1 hour. So this is why count should equal to p divided by threshold. So yeah, if that is not equal to 0, that means they will use an actual hour to finish eating this kind of a piles. For example, that is a 6 modular threshold not equal to 0. This means C will use 2 hours. So why? Yeah, because C need to use the actual hour to finish the left. Left is 2. Yeah, this means the code should plus the P divided by threshold plus 1. 1 is the actual hour C used. Yeah, so this is the final return. If the code should be less than or equal to K, that means the check is right. Yeah. Now let me just run it to check if it really works. So yeah, it's not K because this is 8. We need to check if it is less than or equal to 8 because we used the K as our result. Here is M. Yeah, here is 8. We need to check if it is less than or equal to 8. As you can see, it is okay. Now let me submit it to check if it can pass all the testing cases. After that, I gonna analyze the time complexity. Yeah, as you can see, it's pretty fast and it passed all the testing cases. But for the time complexity, we just need to use m times log n. N is the length of piles. M is the maximum number. It may be 10 to the power of 9. Yeah. If you need exactly to calculate the m, so the piles dot less dot age, so the piles I is 10 to the power of 9. So this means the maximum of the piles should be 10 to the power of 9. So this is n. So m is the length of piles, m times log n. It is a very small number. It may be 10 to the power of 5. Yeah, it's not a big number. So this is why it's pretty fast and we passed all the testing cases. Thank you for watching. If you think this is helpful, please like and subscribe. I will upload more Leetcode problem like this.